Okay, in this video we're going to discuss the laws of logarithms. So there are basically three laws of logarithms. One is that if you have a product on the inside of your log, you can separate that out into two separate logs, and it would be the sum of those two separate logs. The second one is if you have a quotient on the inside of a logarithm, you can separate that out as a difference of those two separate logs. And then the third one is if you have a power on the inside of your log, you can essentially bring that power out front as a multiplication by that log. Those all work both ways. So sometimes we're going to want to take a logarithm and expand it out to simpler logarithms, and then other times we're going to want to take some logs and combine those to get a single logarithm. Okay, so those are the three basic laws, and we're going to go through and look at some of these. The first one we have is log base 4 of 2 plus log base 4 of 32. First of all, in order to combine logs, those bases have to be the same. So make sure that they are both, in this case, they're both base 4. Those have to be the same, otherwise these laws don't apply. Okay, so we have an addition of two different logs, so what we are going to do is we are going to combine that as a product. So we're going to do log base 4 of 2 times 32 and writing that as a single log. So using this first rule, we had a sum, we're changing it to a product on the inside. That then gives us log base 4 of 64. And then we can evaluate that by thinking 4 to what power is equal to 64. And the answer there would be 3. Second one, log base 2 of 80 minus log base 2 of 5. So this time it's subtraction. So we can combine this to a single fraction, to a single log by dividing those things on the inside. So we have log base 2 of 80 divided by 5, which would be log base 2 of 80 divided by 5 would be 16. And then we can do 2 to what power is equal to 16. And the answer there would be 4. 2 to the 4th is equal to 16. And the third one we have log no base, so understood base is 10. Log base 10 of 8, and then we're doing negative 1/3 times that. So this is this third property. What we're going to do is going to bring that up as an exponent on the 8. Bring it on the inside. So we've got log of 8 to the negative 1/3. So that's going to be log, okay, so 8 to the negative 1/3 power. Well, the 1/3 power means root, cube root. So the cube root of 8 would be 2, but then we're doing negative that, so that means we're going to get 1 over 2, right? The fraction means root, the negative means do the reciprocal, so we're going to get that 8 to the negative 1/3 power is 1/2, and then we're just doing log of 1/2. Again, this is 10 to some power is equal to 1/2. That's not going to be a good answer, so I would say at this point just use a calculator to get the decimal equivalent of that, or just leave it as log of 1/2. Okay. The next couple of sections here are just combining logs or expanding logs out. So we're going to use the law of logarithms both ways, where we will look to expand them out or condense them down to a single log. So the first group here is to use the law of logarithms to expand each expression. So we want to write these out to where it's either a sum or difference of several different logs. So number 1, log base 2 of 6x. Well, 6x is a product. That's 6 times x. So I can separate this out into log base 2 of 6 plus log base 2 of x. Right? If it's a product on the inside, it's a sum if we write that out. Log base 2 of 6 plus log base 2 of x. And we're going to leave it right there. We have expanded that out. What you basically want when you expand things out is you just want a single thing there, whether that's a variable or a number. You just want a single thing there. You don't want a product or anything with an exponent or anything like that. So we're done with that one. Second one, log base 5 of x to the third y to the sixth. Again, x to the third y to the sixth means a product of those things. So this is going to be log base 5 of x to the third plus log base 5 of y to the sixth. And then I'm going to use another property, and that is I don't want these exponents here. So if I don't want those exponents, I can bring that out front as a multiplication by that log. So the 3 would come out front, and we would have 3 log base 5 of x plus, bring the 6 out front of this one, 6 log base 5 of y, and we will leave it just like that. And the third one, the natural log, again it's a log, so the properties still apply. Natural log of AB over the cube root of C. So AB, that is a product, that's multiplication of A and B on top, but then we're dividing by the cube root of C. So I'm actually going to use the first two properties here together. We have a product on top, so I'm going to do a sum of those, but then we also have a quotient, so we're going to subtract that third one. So I'm going to have 3 different logs going on here. We're going to do the natural log of A plus the natural log of B, because those are both on top, they're multiplied together. But then the third one, the natural log of the cube root of C, we're going to subtract because it's on the bottom. I'm going to go a little bit further here because remember I want the inside of my log to be as simple as possible. I don't want the cube root of C, so that is really an exponent, right? Cube root is 1/3 power, so C to the 1/3 power means I can bring out a 1/3 and no longer have a cube root there. So natural log of A plus natural log of B minus 1/3 the natural log of C. And again, that's because cube root is the same as 1/3 power, right? That's where we're going there. Cube root is the same as 1/3 power. So we are done with that one. Okay, so that's expanding them out. The second group here is to condense these down and write them as a single logarithm. A single logarithm. It means I'm going to write it as one single log. I'm only going to write log one time in my final answer. When doing this, I would say any number on the outside, take care of those first. So bring those up as exponents. So the 3 goes up as an exponent, the 1/2 goes up as an exponent. We would have log x to the third plus log of x plus 1 to the 1/2 power. Then the addition here means that we're going to multiply on the inside. So we're going to do log, and then all on the inside, we're going to take x cubed, and we're going to multiply by x plus 1 to the 1/2 power. Now I could expand this out a little bit, but I'm not going to. I'm just going to leave it because the directions were to write it as a single log, and we have done that. We have log written one time, log of x cubed times x plus 1 to the 1/2. We're done. Next one, same thing. I'm going to bring the 3 up, the 1/2 up, and the 4 up. So we're going to have the natural log of s to the third plus the natural log of t to the 1/2 power minus the natural log of t squared plus 1 to the 4th. The addition of these, that means that's going to happen on top. So on top we are going to have s to the third times t to the 1/2. Now t to the 1/2, if you choose to write that as the square root of t, it's going to look a little bit better there. You could write it as t to the 1/2, but know that 1/2 power means square root. So on top we have s to the third times t to the 1/2, or the square root of t. But here we're subtracting, so this t squared plus 1 to the 4th power is going to go on bottom because it's being subtracted. And now we have a single logarithm, everything on the inside of that one single natural log.